Okay, we're going to do quite a bit of writing here for the next few minutes because we've got to get introed into what we need to do several different skills. We've got a lot to do today. All right, we are talking about linear equations. That means equations with an x and a y, just like we talked about yesterday. Today is the 23rd. Put your date on your notes. Okay. Linear equations, and we're going to do a number of things with them today. This is the kind of stuff that was half a chapter in Algebra 1, and now we're just going to fly through it. First thing, you know you can take an equation with x and y's like we worked with, and we can rearrange them. We rearranged some earlier this week to make them in slope-intercept form, right? Okay? So you can rearrange equations. There are several specific forms that you can rearrange to. The first one was slope-intercept that we talked about yesterday. Tell me some of the characteristics of slope-intercept form. Anything anything significant about slope-intercept form? Go ahead.
The numbers are usually plotted on a graph.
Okay, you can plot the numbers on the graph from slope, and that's why we do it. Yes, this one's purpose is for graphing. Yes, you make slope-intercept form so that you can graph. Very good. Okay, what else do you know about it? Anything you know about it? That's it. Y equals what? Mx plus b. That's what it looks like. So whenever you get that y isolated, you're in slope-intercept form. What does the m stand for in slope-intercept form? M is the slope. And what does the b stand for? The y-intercept. Good. Jason, you just earned your shamrock. Good. B stands for the y-intercept. Okay, so we've got y equals mx plus b. Used to graph, that's pretty much it on slope-intercept form. All good? All right, I'm going to draw a little line right here. You may not have set yours up exactly like mine, but a second form that you can write it in is standard form. Standard form is somewhat useless. This makes me terribly miss Hunter Bear, who's been coming in my room for 4 years and writing standard form is the best on my boards everywhere. And he's off at Auburn now, so we miss you, Hunter. Standard form is somewhat useless, but it is a thing, and we use it whenever we're solving systems of equations. It looks like ax plus by equals c. Actually, equations come in standard form a lot. You'll see them in standard form and then have to rearrange them to get that y isolated. You've seen that several times this week, haven't you? Where it's written exactly like that, where you have a number for a and a number for b and a number for c. Not a lot of use to it. Okay, we pretty much like them in this when we're going to solve a system of equations. That would be its purpose. Solve systems. But aside from that, standard form is useless. So it's definitely not the best. All right, sort of useless. All right, so that's a second way you can rearrange them. Again, these are not different equations. These are different ways to arrange the same equation. You with me? Nod at me if you're following what I'm saying. There is a third way. Does anybody remember the name of the third form, the third way? We have slope-intercept form, standard form. What's the third form? That's it, point-slope form. Point-slope form. It's a different pattern for arranging these equations. You can take one equation and write it this way, and this way. You following? All right. So point-slope form is a little bit more complicated. Does anybody remember the formula for it? Okay, it's y minus y1, which that right there seems weird, doesn't it? Why would you have two y's? Y minus y1 equals m times x minus x1. Okay, I'm going to take out my highlighters here so I can show you what these are about. Okay, first off, it's called point-slope form, isn't it? All right, which indicates that you do it when you know a point and the slope. So the slope, that part's easy. The slope here is obviously found in this part of the equation. Yes? Does that make sense? There's the slope. What about the point? The point means that you actually know a point in parentheses like an xy value that's part of this equation. You know what the slope is. You know it passes through this specific point, and you insert it right here. This y and this x are where the point comes from. You see why I'm color coding that for you? So what is this other x and y that are appearing in there? It's the variable that stays a variable, just like here you have an x and a y, and here you have an x and a y. This is the real x and y that are going to stay x and y. This is where you actually stick in the point and the slope that you know. You follow? All right, so all of these, this one in particular has a purpose. It is used to write equations. In other words, given information used to write the pattern, used to write the equation. So this one's for graphing, this one's for useless, this one's for writing an equation. All right? Not useless, it's for systems of equations, but it's pretty much useless. Basically useless. All right? And what's funny about it is this one is the one that's the hardest and has the most rules. I may come back and we may talk some more about the rules for writing an equation in standard form. There's 6 of them. It's kind of like insane, all the rules for writing in standard form. We'll probably come back to that at some point. But now, we've got some work to do. So that was my talking. That was my let's learn about the 3 different methods. Now we're going to do the work. All right, so what we're talking about today, today's unit is on writing linear equations. In other words, you're given some data and you're asked to write the equation from the data. All right, I'm starting on sorry, give me half a second. This old book, new book thing keeps throwing me for a loop. I'm sorry, guys. Give me half a second. Roll the old book for a second. I keep consulting my old book because I don't want to skip something important. Okay. All right, open your book to page 32. We're going to start on page 32 together because we've got to look at a graph. That's why we're there. On page 32, we're going to look at problem number 32. Okay, so I'm looking at a graph, and I want to write a linear equation based on that graph. Okay, it's really super simple when you're looking at a graph to pick out the linear equation there, to write out the linear equation, because slope-intercept form is the easiest way to write an equation. And when I look at a graph, can I tell the slope and the y-intercept? Generally, from looking at a graph, you can pick that out pretty easily. All right, so let's start with the y-intercept. Look at that picture on 32. Get your book. Pick out the y-intercept. Kind of touch it with your pencil tip real quick. Okay, now name that y-intercept. What is it? It's a 12. The y-intercept, is it positive or negative? Positive 12, okay? Now, as far as slope, just like we did yesterday, I need to pick out 2 points and then name that slope. So I've got the 12 right there. I'm going to zoom this in super big. I've got the 12. This is not a good place to name the slope. This one, I'm not sure it's quite touching it there either, but it's definitely touching it right down here, isn't it? That's a definite spot where it's touching. So we've got 1 point. Is it crossing at 12? It looks a little iffy, doesn't it? Yeah, your book is counting it as crossing at 12. Okay. To me, it looks like it's not quite crossing at 12, but your book says it is. So crossing at 12 down to here, real quickly on your paper, pick out the slope, the rise and the run. Be careful and think about negative and positive. Pick it out. All right, so we said that the slope-intercept, the B, was going to be positive 12. B is positive 12. And the slope, what are you finding for your slope? Rise of negative 10 over over 6. That's exactly what I had. Good. So negative 10 over 6. Let me back this back out. Now we've got everything we need to write an equation. Will that simplify it all? What does that simplify to, Jesse? Negative 5 over 3. Good. So now we can write our equation in slope-intercept form. It says y equals mx plus b. So y equals m, which in this case will be negative 5/3, x plus b plus 12. Y equals negative 5/3 x plus 12. Was that a question, Max?
Yes, ma'am.
Yes.
Where'd you get the negative 10 over 6 from? Like on the graph. How do you find that?
Point.
Uh-huh.
Point. How much did it rise? Negative 2, negative 4, negative 6, 8, 10. And then how much did it run? Positive 2, 4, 6. I literally take that and I rise negative 10,
Okay.
and you're just counting. Count down, count left. With me?
Oh, okay. Got it. Yes, ma'am.
All right. Okay. I'm going to let that be the one example like that, because we kind of did that skill a little while ago, working on finding the slope. So writing from a graph, we just simply pick out the slope and the y-intercept. Easy stuff. Example number 2. We're going to write an equation, same instructions. All of these we're writing an equation today, given the slope and a point. All right, so I'm going to give you that the slope is 4/3, and it passes through 0, 4. Now, given the fact that you were given a slope and a point, the first thought may be to go to point-slope form, but I would tell you first, take a second and think about this particular point and make sure there's not an easier way for you. All right? Think about where 0, 4 lies on the graph. Is there anything special or significant about that point? Is there any chance that what the point they've given you is the y-intercept? So think about where 0, 4 would lie on a graph. Think about that. 0, 4. Do you see it? 0, 4 actually is your y-intercept in this case, isn't it? Where is this line going to cross the y-axis? At 4. Write your equation. It's going to cross the y-axis at 4, so write your equation. All right, using slope-intercept form, Madison, what is that equation going to be?
Y equals 4/3 x plus 4.
Good. It's to your benefit to stop and think, can I do this the easy way? Yes. Is there any chance that I know the slope and the y-intercept? Ask yourself that every time, okay? Use your problem-solving skills. All right, example 3. You're going to write me a linear equation for a line that passes through 0, negative 6, and negative 4, 10. Take a second and analyze those 2 points. Think about where they would lie on the graph, and think about what information you've been given. Now think about what information you still need. You don't have right here everything you need to directly write the equation. There's something else you need. How can you get it? Think about that for a second. Challenge your brain. What else do I need? How can I get it? What else do we need, Parker? What do I need, whether I'm writing it in this form or this form? I need something. There's something I need either way I write an equation. What do I need? They have something in common. What do I need to write it either way? I need to know the slope, don't I? Do you have enough information to find the slope here? Is 2 points enough? Good, go find it. Find your slope. All right, we've got slope. We knew we had to have that no matter which method I chose to write it. Do I know that, can I do this the easy way? Do I know the y-intercept? Can I use the easy method? Do I know the y-intercept? Laurel's saying I do. What is it, Laurel? If you took a second and thought about it, 0, -6 is going to be your y-intercept. Remember this, the y-intercept, anytime you have 0 in the x spot, you're on the y-axis. If you're at 0 on the x-axis, you're not moving either direction. You're on the y-axis, so we know it. Good, so write the equation. You know the y-intercept, you know the slope, write the equation. Allison, y equals what? -4x minus 6. Any question about that? Okay, those are the easy scenarios. The ones where you're given the slope and the y-intercept, or you can find them, and you're allowed to use the slope-intercept form. Now, let me teach you about point-slope form. Do you remember this from Algebra 1? It's not super hard. It just takes an extra step. You have to do some rearranging frequently. So point-slope form. All right, again, that is y minus y1. You might want to write it again down here, equals m times x minus x1. All right, so the first example, example 4 here, is going to be, you have an equation. You want to write an equation for a line that passes through a slope of -4 and passes through the point 6, -2. I'm going to ask you to let these words sink into your head. Don't just be letting math words bounce off your face. Think about what it's saying. This line has a slope of -4. In your mind, or with your arm, show me, what is the slope of that line going to look like? It's going downhill, isn't it? Pretty steep downhill if it's -4. It's a pretty steep line, and it says it passes through 6, -2. It passes through 6, -2 down here. So it's a steep line passing through that point. You follow? Let's write the equation for it using point-slope form. All right, so what did I say about that first y? That's the real y, isn't it? The one that stays y. What about this second y? What did I say about y1? Yeah, that's the one that's going to come from right over here. It's going to actually come from the point. So it's minus -2. That's coming right there. Equals, now what? Yeah, the m, -4 times, this is the real x, the one that stays x, minus the 6, the x in the parentheses, the x that's part of the point. All right, you follow all that? Follow all that little color coding there where everything is plugged in? Does that help you a little bit? Okay, so technically you've written an equation, right? That is an equation. Now, frequently what they'll ask you to do is to rearrange that into slope-intercept form so that you could go on to graph it, or so that you can compare it to another one, or so, something like that. So let's rearrange that one real quick. You've answered it. Check, that's the answer. Now let's rearrange to slope-intercept form. All right, so the first thing we'll do is what? Say the word. Distribute. -4 times x is -4x. -4 times -6 is +24. What else do I need to do to get y by itself? Subtract 2 from both sides. Y equals -4x plus 22. So both of those are answers. This is the answer written as an equation. This is the equation written in slope-intercept form. With me? All right, so we can easily compare it to other equations. All right, so that's using point-slope form. You try one. Example 5, write it without me. Write an equation. Write an equation in slope-intercept form. That means I want you to rearrange it at the end. In slope-intercept form for a line that passes through 2, 3, the point 2, 3, with a slope of 1/2. All right, go. Write the equation in slope-intercept form. Start rearranging. What is 1/2 times -2? -1. Add 3 to both sides, and you have your answer of y equals 1/2 x plus 2, right? Okay, we got to cram in one last example here because this one's slightly different. For example 6, you're doing basically the same thing. I'm going to put basically the same directions. Write an equation in slope-intercept form for a line that passes through. All right, this one is going to pass through the point -2, 7 and 3, -3. How is that different than the problem you just did? You don't have the slope. You don't have the slope. You didn't have the y-intercept on this one, but you don't have the slope. So we're going to have to use point-slope form because we don't know the y-intercept. And how are we going to get it? How are we going to get the slope? You're going to have to go use your formula to find the slope and then use one of the points to write the equation. Go. Find your slope first. Come on, jump right in. Find your slope. -2, 7 and 3, -3. Once you have your slope, does it matter which point you use to put it into point slope form? You don't use both of them, just pick one. Either one is fine. I'll just do the first one. Make sure you get your signs right. Those are all minuses. Don't just copy down what I'm doing. You need to try it on your own. Let's rearrange it into slope-intercept form. All right. Understand what you're looking for? You got to have slope. If you have the y-intercept, use the easy method. If you don't have the y-intercept, use the point slope method. Got it? All right, take one of these and press that. We're going to skip the top portion for now and just start working at number 9. I want you to do 9 through 19 odd. 9 through 19 odd. I want you to practice what we just did for homework. Work extra hard. Don't skip any. We're going to try to take it for a completion grade tomorrow. 1-4 worksheet. 9 through 19 odd. All right. And you may start putting your books away before the bell rings. Yes, Max?